Okay, this is Chapter 12, Supervised Data Mining. Our learning objectives: explain key differences among supervised data mining techniques, apply the k-nearest neighbors method to classify new records, apply the naive Bayes method to classify new records, and let's get started. This is the introductory case, 24/7 Fitness Center, annual membership. 24/7 Fitness Center is a high-end, full-service gym and recruits its members through advertisements and monthly open house events. Each open house attendee is given a tour and a one-day pass. Potential members register for the open house event by answering a few questions about themselves and their exercise routine. The fitness center staff places a follow-up phone call with the potential member and sends information by mail in the hopes of signing the potential member up for an annual membership. Janet Williams, a manager at 24/7 Fitness Center, wants to develop a data-driven strategy for selecting which new open house attendees to contact. She has compiled information from 1,000 past open house attendees. Janet also collects the age, income, and number of hours spent on weekly exercise from 23 new open house attendees. Here is the data worksheets that we have here. Janet would like to use the data to accomplish the following tasks. Number one, develop a data-driven classification model for predicting whether or not a potential gym member will purchase a gym membership. Identify which of the 23 new open house attendees are likely to purchase a gym membership. The goal is to classify or predict the outcome of a new observation case record. Classify a categorical target response outcome. Predict a numerical target or response outcome. Scoring a record. Classifying or predicting the value of the target variable of a new observation given values of the predictor variables. So there's two worksheets: data, find the preferred data mining technique, and two, score, predict the target of new records. Use cross-validation to avoid overfitting. Performance metrics. In classification, TP, TN, FP, FN, cumulative lift chart, a decile-wise lift chart, ROC, and then prediction, RMSE, and MAD. Introduction to supervised data mining. This is some of the techniques that we have here, and then we have the advantages and then the limitations to each of them. I'm not going to read this. You can see this on your own when you review the chapters. The k-nearest neighbors, or KNN method, is a memory-based reasoning technique. It's simple yet effective, frequently used, and produces highly accurate results. Time-consuming and computationally expensive. It uses observations from the past that are the most similar to new observations to classify or predict the target variable. Known to be a very effective classifier but less popular as a predictor. It does not assume an underlying distribution, non-parametric. Traditional methods require the predictor variables to be numerical, transform categorical variables to numeric. KNN identifies a number of existing observations that are most similar to the new observation for classification. There are two components: similarity measures, typically standardized, and Euclidean distance. And the second one, number of nearest neighbors to consider, K. Search the entire training data set for the most similar observation. Provide a score for the new observation. Use data partitioning. Evaluate model performance and optimize the complexity. Experiment with a range of values for K. Example. Consider a mortgage company trying to determine whether or not a new applicant is likely to default on his or her home loan. The new applicant is 36 years old and has an annual income of $64,000. The mortgage company extracts information from 10 previous customers with similar income. And below you can see the chart. It's charted out. Example. Recall from the introductory case that Janet Williams, the membership manager at 24/7 Fitness Center, has collected data from 1,000 past open house attendees and 23 new open house attendees. Janet would like to develop a model that identifies attendees who are likely to purchase a membership. Use past data to implement K&N for classification, and compute and interpret performance measures and charts. And lastly, score the new records. For cross-validation, we will use only the holdout method or the k-fold method to develop and evaluate the K&N classification model. This is an example. Continue with Excel. Continued example with Excel. Same thing here. And then we also have it with R. Okay. The naive Bayes method. The naive Bayes method is a family of classification models used to predict the probability that a record belongs to a particular class. It is based on Bayes' theorem. Use new information to update the prior probability to form a posterior probability. Let Y be the response and X be the predictor, utilizing this formula. The target variable has two classes. The predictors must be categorical. Transform numerical predictors to categorical by binning. Estimating posterior probabilities can be cumbersome when the number of predictors is large. For computational simplicity, the naive Bayes classifier assumes that the predictor variables are independent. Note realistic, hence naive. It doesn't capture the possible interaction between predictor variables. This method is simple and can conform well in many real-world situations. The underlying concept of naive Bayes is quite simple to understand, easy to implement, and especially attractive. Here's an example, customer purchase by gender. You've got your chart here, and then your formulas. Several predictive variables are used for classification. Let Y be the response and X sub 1, sub 2, etc. be the categorical predictors. Plug in the variables and assume the predictors are independent of one another. The classification rule is given below. The classification rule, this is the formula below. Since the probabilities have the same denominator, we only need to compare the numerator. An issue that is rare or not present outcomes in the training data. The probability becomes 0. No new records will be classified to such a category, and replace the 0 probability with a non-zero value, which in most cases is usually just 1. Because the naive Bayes method is a supervised data mining technique, data partitioning is used to assess model performance. Unlike the K&N method, the naive Bayes method does not use the validation data set to optimize model complexity. It is customary to partition the data into training and validation sets. The training data are used to compute the conditional probabilities. The validation data are used to assess the performance of the naive Bayes model on a previously unseen data set. Example: help congressional offices gain a better understanding of U.S. residents whose incomes are below the poverty level. The data set has 9,980 observations and includes the following: marital status, sex, ethnicity, age groups, whether or not the individual receives college-level education, and whether or not the individual's income is below the poverty level, and records of 66 new individuals with the predictor variables. Here's a chart that is answering all of the questions that were in there. So to develop the naive Bayes model to classify whether or not an individual lives in poverty, using all 5 predictor variables. Compute and interpret the relevant performance measures and performance charts. Score the new records, and then partition the data into 2 sets, training and validation, using the holdout method. Here's the example that we did with Excel. More Excel, we show the charts. Continued. Then with R. Right by the stairs. Okay, Well, thanks for listening. Have a good day.